You type a URL, hit enter, and in under a second, a website assembles itself out of thin air. Here's every gear turning inside that second. First off, your browser asks the internet's phone book, DNS, to translate that domain name into an IP address. That domain name itself, the yourname.com part, isn't owned. It's rented from a registrar every year, forever, like digital land tax. .com, .io, .dev, top-level domains are basically neighborhoods, and some neighborhoods charge a lot more rent than the others. Once your browser has the address, it just fires a request across the wire to a server, a computer that's just always on, always listening. That always-on computer lives in a hosting, a physical machine in a data center, or more likely, a rented slice of someone else's giant cloud. The server hands your request to the backend, the part of the app that nobody sees, that decides what you're actually allowed to have. This is where the backend languages live. Node, Python, Java, Go, Ruby, all quietly convinced that they handle requests better than the others. Most of the time, the backend isn't inventing an answer, it's checking a database, like Postgres or MongoDB, to hand over the real data. That whole conversation happens through an API, a strict little contract that spells out exactly what can be asked for and what comes next. The backend packages an answer and sends it back across that same wire, and now it's the front end's problem. Front end is everything you can actually see and touch, built from three ingredients that never change: HTML, CSS, and JavaScript. HTML is the skeleton, CSS the outfit, and Java is the part that makes it actually do something instead of just sitting there. Nobody handwrites raw JavaScript for big apps anymore. React, Vue, Angular, Svelte all exist purely to stop you from repeating yourself into madness. On your phone, none of this changes much. It's the exact same request and response, just squeezed through a smaller screen and a shakier signal. Before any of that code existed, a designer already decided where every button goes, usually in Figma, turning a blank page into a decision about human behavior. Good products reuse a design system, one shared set of colors, fonts, and components, so the app doesn't feel like 5 different apps stapled together. But before any of this reaches you, it goes through QA. People whose entire job is trying to break what everyone else just built. QA is making sure the process behind building it doesn't produce bugs in the first place. QC is actually checking the finished thing before it ships. Unit test checks tiny pieces. Integration test checks pieces working together, and somewhere someone is still manually clicking every button anyway. Nothing goes straight to real users. It goes to staging first, a fake copy of production, where mistakes are completely free. Getting a code from a developer's laptop to that live server without breaking every time is its own entire job, DevOps. Every push triggers a pipeline, CI/CD, that automatically tests, builds, and ships the code. So no human has to remember 40 manual steps in order. Most of this runs inside containers, usually Docker, so it works on my machine finally stops being an acceptable excuse. Scale that up and you need orchestration, Kubernetes, deciding which server runs which container, and restarting anything that quietly dies. And once it's live, monitoring tools watch every single request, just waiting for a reason to page someone at 3 a.m. So, the full trip: domain to DNS, request to server, backend to database, response to frontend to your screen. Dozens of separate systems agreeing to pretend this was instant. And that's the trip for one person, one request. What happens when a million people hit that same site in the same second? That is a completely different problem.